every time you receive a particular project, it would be a different case altogether. So there is no one particular rule of thumb which would be there for all the projects that you would receive. But that doesn't mean that the approach cannot be defined. So the most important part in any network design project is to define the approach. Let me show you something first. Right, I'll show you this particular part. What happens? What is the first thing that comes to your mind when when you take care of a network design project? What was the first thing that came to your mind when you saw this project? Anybody can volunteer and answer that.
Yeah, Kuldeep is raising his hand. Kuldeep,
Yep.
you can say it. Yeah.
First, when I saw this case, so I just tried to figure out like what kind of network it is already having, and how we can make the distance shorter, like clustering kind of thing. How we can do that, because since we have a vast network of demand locations, so first thought was to cluster it and then approach it. So such kind of approach we have thought of initially.
Correct. So whenever you receive a particular project, the first thing that comes to mind is how am I going to solve this? Whether I'm going to solve this on Excel, whether I'm going to use any external tool for it, any other software for it. That is the first thing that comes to your mind. How am I going to solve it? Uh, Before we get into the part wherein we are even thinking about solving the problem, the first thing that we need to focus is this particular area. What kind of data do I have versus what kind of data do I need? Right? What kind of data I have at this point of time and what kind of data do I need? Then once I have all that data, I would create a particular data model which would be used to handle that data. Why is data modeling important? We gave you a particular set of data at this point of time, and this could be very well historical data or a forecasted data or anything. What happens if I change the data, in the middle of the study? Are you going to do the whole activity from the start again? That is why you need a data model. And I'm talking from the real time point of view, real time scenarios. So you need to create a data model at that point of time to handle the data, and then you would have to find out, you would go to that question, how am I going to solve it? So solving comes at a later stage in the analysis. The first thing is what kind of data do I have? In any network design study, you need three kind of data. You need the flow data where the cargo is flowing from. You need master data. What kind of locations do you have? And then you would need the external data. So additional data, which would not be available internally. Like I don't, I would not take the remember the name of the team, but there was one particular team which in their presentation has also mentioned. If I'm opening up a warehouse at a particular location, do I have any logistics parks nearby? Do I have any seaport nearby, etc.? So what kind of external data do you need in that particular study? And then there are data models. I'll not go much into detail into that particular part. But what happens once your data is modeled? What happens when your data is created? Hold on, I'm getting some lag here. Right. So what happens when your data is created? What is the first thing that you're going to do? Most of the participants, and in the real time situation, this happens. Most of the analysts, they jump to the to be analysis part. We are very eager to find out what we are going to do in this particular analysis. There was one particular team which was also focusing a lot on the as is scenario. So the first thing, whenever you receive a particular project, the first thing that you need to do at that point of time is establishing a baseline. It is extremely, extremely important to establish a baseline. How are you going to establish a baseline? Let me show you something else as well. Or let me give you a particular scenario. Let me give you a particular scenario. You have a particular case wherein you have primary transportation movement, secondary transportation movement, tertiary transportation movement. You have maybe your warehouse cost. fixed, and warehouse cost variable. These are the 5 types of costs that you have in hand. Whenever you are working on a particular project, let me give you an idea that the total transportation or the total cost is 50 CR. Is this going to be your baseline cost? Are you going to compare all your to be cost with this particular cost? So 50 crore is the amount that an organization is spending on these 5 types of cost, and this is the reference cost technically for the organization. But whenever you are doing the study, are you going to use this particular cost as the baseline cost? So the answer is no. So you cannot use this particular cost as a baseline cost. Why cannot you? Why can't you use this particular cost? Because whenever you're doing a study, you're going to have a lot of assumptions in picture, right? We call them considerations. So we'll take a lot of considerations in picture. We would also do a lot of consolidations, right? So for example, in this particular case study, you received a lot of transportation costs for different types of the vehicle. Most of the participants, when they worked on a particular project or this particular project, they considered one particular type of the vehicle. Why did you consider one particular type of the vehicle? Because you thought that that particular type of vehicle would require less trips and hence would reduce the total cost. What would happen if you consolidate them? So let's say you have five types of vehicles, you have 5 different weight categories, you have 5 different cost categories. What would happen if you take an average out of them? In the raw data that you have received, nowhere you received the vehicle details, right? In the tertiary movement as well, in the primary movement as well, in the secondary movement, everywhere you had the weight consolidations. So for example, you have factory number 1. And you have 3 such factories. Similarly, you have warehouse number 1 and you have 5 such warehouses. And let's say you have, I don't know, the customers. Let's say you have customer number 1 and let's say you have 20 such. Let us say you have 20 such customers. In all the data that you have received, you had received the replenishment data. So, you know how much material is going into the warehouse, how much material is going into the customer. Nowhere you had the uh, nowhere you had the vehicle details. So how many vehicles of each type is being provided to cater to this material to warehouse number 1? How many each type of vehicle is provided for the movement from warehouse number 1 to customer number 1? You did not have that data. Now, when you use 32 feet of Excel, for example, as an assumption, and you do the whole, you take out the whole output, you cannot compare it with this 50 CR, right? Because in the real-time scenario, you don't know whether only 32 feet MXL is being used or there are, combination of all the vehicles that is being used. So in such scenarios, you would use the consolidation part. So you would consolidate, you would average out the capacity of the vehicle, you would average out the cost of the vehicle, and then you would come to your truck capacity and truck cost. Now, this particular truck capacity and truck cost that you have come to becomes your consolidated cost. So there are 2 activities that you would do at this point of time. One is consideration, one is consolidation, and you would find out the revised truck capacity and truck cost on the basis of these considerations. For example, you also did not have in the raw data, you also did not have the capacity of each vehicle. So those would go into consideration. So what is the capacity of SXL, MXL, Tata 407, etc. And then you would consolidate it. What would happen once you have completed these activities? So let's say your truck capacity came out to be 20 tons. And your truck cost came out to be 55 rupees per kilometer. What would you do with these numbers? You would use these numbers to simulate your baseline. So whenever you're working on a data, you will take your as is actual, then you will simulate that as is actual scenario with assumptions and consolidations to find out a simulated baseline. Now this becomes your base figure, and whenever you're working on the to be analysis, you would always compare your to be scenarios with this number. This would make your life easier as well. I'll tell you why. Uh, I, Again, I don't remember which team, but there was one particular team which has also mentioned, that the case was becoming too complicated, so they did not consider the tertiary movement, etc. So these kind of scenarios would happen, right? So the cases would become too complicated. No matter what kind of software you're using, it would always be one particular scenario wherein your data set is exceeding the limitation of that software. So the cases would become complicated as you go. As a simulation would help you with that as well. So whenever you're simulating, you would have an opportunity to reduce your data set as well. All that all that matters at that point of time is that you would use the same consideration and same consolidation in your 2B scenario as well. Similarly, whenever you're doing this particular activity, it is extremely important to record the assumptions as well. Again, I remember one particular team wherein they compared the 2B cost with the as-is cost, and in the 2B cost, they had a particular assumption that they have taken in terms of the truck capacity. And I asked them, whether you have taken the same assumption in your as-is scenario as well when you did the comparison, and they did that. So they, in a way, simulated the as-is cost as well. However, it is extremely important that when you have the opportunity, in which scenario would you be consolidating, in which scenario would you be using the considerations. According to me, the priority should be given to consolidation. So if you have 5 particular type of details available, it would be important if you average them out and have a consolidated opportunity there. The cases wherein you do not have any detail, it is important to go for the consideration part. Right. So now coming to the next part. The next part, according to me, is extremely important. What are you going to do in the 2B analysis? What is the main factor which would drive your 2B analysis? According to me, the main factor that would drive the 2B analysis is the cost identification of cost relations. So it is extremely important. Just give me 1 second. Right. So it is extremely important to identify the relation between cost. Okay, let me ask you one question, and it's a very basic question. What would happen if I come to you and I tell you that I have 500 warehouses, I have 3 particular factory, and I have only one purpose in mind, to make my warehouses cost to be the minimum? How many warehouses do I need in between? Can anyone answer that? Right. So answer to that is 0. So you do not need, if my only purpose in that study is I do not need any particular warehouse cost on my head, I do not need any warehouse, right?
Sorry, we had one hand that was raised, but it just, I don't know. That was
Okay.
that was Mayank, is it?
Yeah, ma'am.
Yes, Mayank, you can answer if you want.
Actually, I was just want to say that the similar problem can be solved with weighted distance. That is the only thing I just want to share. How many warehouses we have to open? If there is minimum constraint that this much of warehouses has to be open.
You're right. But what if the only constraint that I have is I do not need any warehouse cost?
Then it would be 0.
Correct. So then I do not need any warehouses. What would happen if I turn this other way around? What would happen if I tell you that I want my transportation, my secondary transportation cost to be 0? So I have the movement from factory to warehouse to customer, and now I do not want any transportation cost. How many warehouses do I need in that case? And when I say transportation cost, I mean secondary transportation cost.
Then of course we need warehouse at each and every customer location, like
exactly. So if you have 500 customers, in that case, you need 500 warehouses, right? So then your secondary transportation cost would be 0. What we understood from this is the cost relation. So your warehouses cost is always inversely proportional to your transportation cost, right? So if your warehouse cost is increasing, your transportation cost is reducing. Similarly, when your warehouse cost is reducing, your transportation cost is increasing. Our job is to understand how it would impact the total logistics cost. So for example, let's take this scenario. So this is your number of warehouses. You have 10 warehouses at this point of time, and you have the transportation cost as well. So when you have 10 warehouses, the transportation cost is 10,000 rupees. When you reduce to 9 warehouses, your transportation cost is slightly increased. But what happens to your overall logistics cost? It has reduced. Similarly, when you reduce it one more, if you have 8 warehouses, your transportation cost has increased, but your logistics cost is still reduced. If you reduce your warehouse cost by one more, you have 7 warehouses. Your transportation cost has increased, but your logistics cost has also increased slightly. So now you found a valley point. So this is the point that you have to identify in your 2B analysis. Whenever you're doing a 2B analysis, you have to identify the balancing point between your various costs so that your total logistics cost would reduce. And this is the fundamental of the 2B analysis. The first thing you need to identify is how the how many different costs are there and how these costs are related to each other and impacting the total logistics cost. I also remember most of you have figured out that in the case study that we have given you, the transportation cost has the logistics cost includes maximum transportation cost and very little warehousing cost, which means that whenever you're doing this analysis, transportation cost becomes your most important part of the analysis. And then you would identify the methodology of the optimization. So what kind of methodology are you going to use? One particular team has also suggested, they did not use all the methodologies, but they also suggested 3 different methodologies that can be used for this particular purpose. So that is one more step towards 2B analysis, wherein you would identify what kind of methodology you're going to use. So once you have finalized the methodology, you would prepare the scenarios under that methodology. So you will stick to that part and you will prepare different scenarios. This is something, so whenever we come across such case studies, we always find that there are 2 things that is missing in the whole analysis. One is simulation of as is to create a baseline, and second is preparation of scenario. Every analyst is very eager to find out that one perfect scenario, because we all think from a mathematical point of view, right? There is only one right solution and we have to find that right solution. But in the practical purpose, that is not the case. No one right solution would be operationally feasible. So if you go to the organization and say that you have 15 warehouses, I think you should have 12 warehouses and 3 warehouses should be closed. The organization would come, the operational team would come back to you and say that, we cannot close these 3 warehouses because one such warehouse is very important for you, or one out of those 3 warehouses is our own property, not a rental property, and we cannot close that one. Can you suggest any other one? So it is always and always extremely important to prepare the scenarios. In this particular case study, we were not bothered about the solution. So we were not bothered about the final number that you have 100 CR as the actual cost, and if you optimize it, the final number would be, I don't know, 85 CR. That was not our idea. Our idea was to identify how you have approached this project and what kind of output you are preparing. So that is why it is important to prepare different scenarios. Once you prepare different scenarios, then you would go into the validation stage. How would you validate these scenarios? So you would validate these scenarios, number one, which is the primary concern, on the basis of cost. And this is where the mistakes happen, right? When you are preparing the scenario, you are only preparing the scenario on the basis of cost. That should not be the case. Once you prepare the scenario, then you would validate them on the cost, and then you would validate them on other criterias as well, which is, a requirement of the study. For example, the service level. So now you would validate it on the basis of service level as well. You would also validate it on the basis of maybe inventory, carrying capacity of any warehouse, any kind of so for example, if you're dealing with a temperature sensitive cargo, so what kind of capabilities do you have in those warehouses, etc. On all those criteria, you would do the validation part. And this is practically how you would approach these scenarios. How do we come in picture? What does LogUp do? Do you all know what we do, who we are, etc.? So I'll still say that So LogHub is actually a software organization. We develop the softwares for data, supply chain optimization. We are strictly limited to the supply chain part of the industry. So we develop softwares in the supply chain optimization part. We do develop some softwares for simulation as well, some software for analytics as well. But does our work, is our work limited to the development of the softwares? No, that is not the case. We have a huge consultation area as well, which we cater to. So we take care of a lot of consultation projects as well. We take care of a lot of solution designing, subletting of projects from bigger consultation organizations as well. So we do a lot of activity in the consultation part as well. How do we take care
Sorry
of?
to,
Yeah.
sorry to
Yes, please.
interrupt. I think Druman, do you have something to say? Because I saw your hands raised.
No, I'm just about answering the sir's question about LogHub. But
You
sir,
may
I
go
forgot it.
ahead.
Okay.
Okay. Okay, not.
Right. So let me quickly give you an idea as to who we are, what we do, and what kind of softwares do we create. Um, we also create solvers to problem various, various supply chain problems. We also create simulators. We also create analytics softwares, etc. And we use all these softwares in our own consultation project as well. So whenever we do a consultation project, we don't use any external software. We use only internal software, that is supply chain apps. Let me show you, these are the kind of applications that we use. So we have divided, and this was carefully designed, in order to cater to the most part of the supply chain. We have designed our software to cater to end-to-end part of supply chain, including the upstream part of supply chain, downstream part of supply chain, etc. So you can see that our solvers include the center of gravity study. Our solvers include the network designing part of it, location planning part of it. We do have some solvers for forecasting as well. So these are the forecasting solvers based on artificial intelligence. Some organizations use the traditional methodology like ARIMA, etc. For forecasting. So we do have solvers for that as well. Then we have solvers for last mile planning, route optimization, Milton optimization, etc. And then we have solvers for inventory analytics as well, like inventory simulation, ABC, XYZ classification, etc. So all these solvers are used for various purposes. It is not important to have, only to have these solvers. What would happen if I am an analyst, or if Franjali is an analyst in a particular organization, and I would hand over these solvers to her? Would she be able to solve the problems after receiving these softwares? The answer is no. It is not only necessary to have these solvers, it is also necessary to know what these solvers are doing. So how are we doing the center of gravity analysis? Okay, so let me also show you a little bit about center of gravity analysis. Let us say you have one particular customer. So let's say you have a particular case wherein you have two customers, more than that. And your customer number one in the year 2021 has a demand of, let's say, 200 and or let's say 25,000 kilograms of material. Your customer number two in 2021 has had a demand of 15,000 kilograms of material. Now, if you receive this particular study and you need to identify a location of the warehouse uh, to cater to these two customers only, and you have to do this analysis on the basis of demand that they have generated in 2021, where do you think the warehouse location should be?
So nearby customer one.
Correct. So it should be near customer one. What would happen if I add one more customer here? And now this particular customer has a demand of, let's say, 30,000 kilograms of material. Your appropriate location should be somewhere here. What would happen if I add one more criteria? What would happen if I tell you that, I am not only considering the demand of the customer in terms of weight, I'm also considering the demand in terms of volume, because my SKU bifurcation is such that I have some particular SKU which has a gross weight of let's say 100 kg, and they are volumetric in size, so they have 5 cbm of volumetric weight, versus I have another SKU which has a gross weight of let's say 500 kgs, and they are very dense SKUs, and they have volumetric weight of 2 cbm only or 1 cbm only. So I want to consider both the criteria. So I want to consider weight as well, and I want to consider volume as well. So then this problem would become much more complicated, right? Then you would have to identify on the basis of not one parameter, but two parameters. What would happen if I tell you I don't have 3 customers, I have 3,000 customers? Then this problem would become much more complicated. And now what would happen if I tell you I don't need one warehouse, I need 50 warehouses? And then this problem would become super complicated. And now what would happen when you deal with certain problems? And that is where center of gravity comes in picture. For those of you who are not aware about how the center of gravity analysis is done, just to give you an idea, whenever you're dealing with these two customers and this one is demanding 25 tons of material, then in the center of gravity, you would apply a weight towards a force towards this particular customer equivalent to 25 tons, and apply a similar force towards this particular customer equivalent to 15 tons. And then you would identify the balancing point. So then you would identify, and that's why it is called barycenter analysis or center of gravity analysis. So you would identify the point which balances these two forces, and that would be your most optimum location. So whenever you are adding more and more customers to it, this analysis would become more and more complicated. And that is where our solvers would come in picture. But it is extremely important to identify how the solvers are working. Let me also give you another scenario. What would happen if I am working on a particular case wherein I have two vehicles, truck 1 and truck 2, and I have one shipment? How many possibilities do I have in this scenario? I have two possibilities, right? Either I can send the material from truck 1 or I can send the material from truck 2. What would happen if I increase the number of shipments? What would happen if I have two shipments? How many possibilities do I have?
1, 2, 3. 3.
So I have 4 possibilities.
Oh,
Right. So what would happen if I add one more truck to it? Possibilities do I have now?
6.
6.
6 possible. That is 2 raised to power 3. That is the number of possibilities. What would happen if I add truck 4? Then 2 raised to power 4. So whenever you are working on a scenario wherein you have to understand the possibility, we gave you how many trucks? I think we gave you 5 type of vehicles, and you have X number of shipments. So now your possibility, number of possibility would become number of shipments raised to the power of number of trucks. And these many possibilities you would have. And then you would have to identify which one is your lowest cost. Complicated problem, correct? You can still do it in Excel. It's not that you cannot do it in Excel, but it would take you a day or so to do this particular activity in Excel. Whenever you're using a solver, like this, you would be able to do that activity in minutes. So practically, if you receive a particular project and you have a project to finish in, let's say, 1 month of time, when you're using a particular solver, you can finish that activity in 7 days of time. So that would reduce your time, but it is still important for you to understand how these solvers are working, what kind of activities these solvers are doing. Every solver has a particular uh, particular use, and on the basis of the study, you would identify which solver to use at what point of time. You would also be able to identify um, which solver's output should go as an input in which solver. So for example, if I want to do a center of gravity analysis and I would identify 50 odd location of the warehouse, now I would have to validate these warehouse. And I would validate it on terms of cost, on terms of service levels, etc. And I would use the output of center of gravity into the next part of my study, maybe network design, maybe location planning, depending on what kind of study I'm doing. And that is how I would define the whole project timeline. what would happen if I give you a particular scenario wherein the material is going from factory? Let's consider this scenario only. So material is starting from factory, it is going to RDC, it is going to regional distribution centers, and then it is going to customers. Now, in your whole objective, you had only, so let's consider these nodes, right? We will call this sender node. If the material is starting from there, this would be transit node 1. This would be transit node 2. And this would be receiver node. Now, whenever you're doing this particular study or any such kind of study, your whole idea is to optimize these transit node. You cannot change your receiver node, and in all probability, you cannot change your factory node as well. If you can change your factory node, that would be a completely different kind of study. But in the network design activity, your whole idea is to optimize. Yes, please. Anybody has any question? Okay, no problem. So the whole idea of the study is to identify or optimize or realign the transit nodes. So our whole world in the network design revolves around it. So what kind of transit nodes do I have? How can I optimize it? This is the major question. When you have to optimize multiple transit nodes, like in your case, I think in your case, you had to optimize 3 transit nodes. Which is the transit node that you would have to identify or optimize first? Where would you start from? Any answers on that? I think there was one particular team which did exactly that. So, or I think all of them did exactly that. There was one particular team to whom I asked this question as well. So, if there are no volunteers, I'll just.
Yeah, Ritik, you may continue. Yeah.
Okay, so whenever you are identifying the transit nodes and whenever you have to optimize these transit nodes, it is extremely important to understand which is the impact node. We call that the impact node, which is the impact node in the whole study. What is an impact node? Impact node is the node which is controlling the demand, which is controlling the whole flow of the network. In this case, or in probably all the cases, unless you're doing an upstream supply chain, in the downstream supply chain, your customers are your impact nodes. Your customers are controlling the demand. So this becomes your impact node, and the transit node, which is catering to this customer, should be started from. So you would always start from transit node number 2, that is your distribution center. Once you optimize the location or align the distribution center to your customers, you would start with your regional distribution center, and then you would optimize or realign the regional distribution center as well. So it is important to identify where would you start in your study. What would happen once you have completed this particular study? You have used the consolidations, you have used the considerations, that the same consolidations and considerations you have used to establish a baseline as well when you have simulated the as-is scenario. And now you would prepare multiple scenarios. So let's say in your as-is scenario, you had 10 distribution centers, you had 4 regional distribution centers, and now you would prepare multiple scenarios. Scenario number 1, let's say you have optimized this distribution center, your new number is 8. You have optimized this regional distribution center, your new number is still 4. So there is no optimization in that area. That becomes your scenario number 1. In scenario number 2, you clubbed your distribution center and regional distribution center and identified how much of material can be transported from RDCs directly to the customer. And let's say in those scenarios, your distribution center becomes 6 and your regional distribution center is still 4. In next scenario, you have not optimized your uh, distribution center, you have kept it, or let's say you have optimized it and you have got 8 as a number, but now you have identified the opportunity to supplying the material directly from the factory to the distribution center, and hence you have optimized the RDC as well. Let's say your RDC is 2. So these become your 3 to be scenarios: scenario 1, scenario 2, scenario 3. And now you would validate these scenarios. Now you would compare these scenario with your simulated baseline to identify what kind of cost saving you are you are expecting. The cost that you are getting out of these scenarios is not your final cost, right? So let's say your total actual cost was 5 CR. When you have simulated it on the basis of assumptions, you have created a baseline. Let's say your baseline becomes 4.5 CR. And when you have simulated your 2B scenario, your 2B scenario cost would become 4 CR. Now this 4 CR would be compared to this 4.5 CR to identify what kind of cost saving are you expecting. Let's say it is 11%. 11% cost saving you are expecting, and now you would apply this 11% to the 5 CR actual figure to identify what kind of cost saving are you expecting now. So now this whatever new number you would come up to after applying that 11% of cost saving, that would become your new 2B number. And that is where your study would be completed. So this is, according to me, the ideal way to take care of these kind of studies. Now, what do we do? So, some of you would win in today's round, some of you would lose in today's round. But in any of the case, what is going to happen? So to the winner. So winners would not only get access to our application, so these kind of solvers, but we also run a training program. So we run a training program wherein we do two activities. Number one, um, we train the participants on our solvers. So we train them how to use our solvers and we certify them at the end of the program. So they would be certified to use these applications, and then this certificate would be used in or recognized in various organizations. So we have organizations like McKinsey, Deloitte, who are using our solvers. We have manufacturing organizations like Nestle, Coca-Cola, Aditya Birla, etc., Unilever, who are using our applications. So this certificate would be recognized in these organizations as well. But that is not the purpose. So that is the add-on benefit. There is also one more thing that we do in these training programs. We not only train the participants on our applications or on our solvers, we also train the participants on supply chain methodology. So we have three modules of supply chain methodologies, which we train the participants on. One is the approach to supply chain, second is approach to data structuring, and third is approach to predictive analytics. So what kind of predictive analytics methods can you use in your real-time supply chain projects? So these are the three modules that we train the participants on. So with that, I wish you all the best, for the results and for your future as well. Once you complete the program that you're studying for right now, and I would now like to hand over to Pallavi for the winner announcement.
Yeah, thanks, Ritik. Thank you so much for all of you, for all of the words just now you said. This means a lot for every student, I guess. We understood how to solve the case study from as a scenario to be scenario. So it was a great session, I would say. So yes, moving forward to the results declaring round. So I would love to, ask all of the students to turn on your camera so that I can see all of you. And Vrinda, is everyone there? Like some of the students were in class. Are all of them here?
Yes, yes, they're here.
Okay, okay, okay. So thank you guys. You everyone did a great job. But it's a game. If someone lose, someone wins, so that is not a worry point for us. But yes, we will keep succeeding in our life like this only. So just to announce the results, let me share my screen so that I can show you the slides. Please let me know when you guys can see my screen. Yeah. Hope everybody can see my screen now.
Yes.
Yes, ma'am.
Yeah. Okay. So first to start with the second runner-up for today. So who will get cash prize around 5,000 from IIM Nagpur, along with 50% discount on LogHub certification program, along with free LogHub 2 lakhs for 2 months worth rupees 2,80,000. So this position goes to, any guesses, guys, from your end? No? Okay, cool. Who would like to guess? Yes, that's so nice. Yeah. Okay. So it goes to Happiest Minds, Mahima Rathor, Kumar Piyush, Kuldeep Prajapati. Congratulations, everybody.
Congratulations,
Thank
guys.
you. Thank you very
Yeah.
much.
Thank you, ma'am.
So you did a
Thank you,
great
ma'am.
job. We really like the presentation and everything. So keep succeeding. Yeah. So moving forward to the first runner-up. Yes. So the first runner-up will get 10,000 cash prize from IIM Nagpur, along with 50% discount on LogHub certification program, along with free LogHub 2 lakhs for 2 months worth rupees 2,80,000. So this is huge, guys. This is huge. So this position goes to Transformers, Pratik Sawant, Dhrumin Patel, and Rupa Mittal. Congratulations, guys.
Congratulations, guys.
Thank you.
Congratulations.
Thank you, panel.
You guys really did well. Like one of your participant was not there, but still you managed to score within first runner-up position. So this is commendable.
Thank you, ma'am. Ma'am, just a small thing. It's Rupal, Rupal.
Rupal. Okay. Sure. And maybe some typo. Yeah. Thank you.
Congratulations.
So here we are. The last, the most important one for the day, the winner of this event, who will get 15,000 INR from IIM Nagpur and free full certification program, along with LogHub tools access for 3 months worth rupees 4,33,000. So I'll not wait for long. It goes to challengers Kurmana Sandeep, Malipati Kalyan, and Mali Sai Krishna Reddy. You guys are winner for the day. Congratulations, guys.
Thank you very much,
Congratulations.
ma'am.
Congratulations, Sandeep.
Thank you very much.
You guys really did a great job. We love every aspect of the presentation today. So from Excel to how you presented and everything, how you made the PPT. So it was great. We loved it the most. And for the other teams, the finalists, this is last but not the least. There is something for you as well, which is 25% discount on LogHub certification program, along with free LogHub access tool for 1 month. So this is also great deal for you guys as well. So thank you.
So it was really tough for us to decide. It was a very close competition. We did we did mark you on I think 5 different categories. So one is obviously the PPT design. Second is how innovative you were in your solutions. We also marked you on the conclusion and accuracy of the solution. However, we did not, follow it up to the dot, wherein we did not just compare the numbers and everything. We compared more on the kind of solution that you have provided. So what all areas you have covered in the solution part, and how you compared it with the actual scenario. Then we marked you on the methodology that you have followed, and then we also marked you on the confidence. I would say that looking at the numbers that we have given, confidence is something in which you guys get full marks because I didn't see anybody who was lacking even a little bit there. I understand that this could be challenging. It's a complicated project, and we had some questions as well for you. But that is something in which you guys got full marks. Even in the methodology part, you guys were very, very innovative, and keep shining, keep being creative. That would go a long way.
Yes,
Okay.
thank you, Ritik. Yeah, over to you, Akansha.
Yeah.
Yes.
So
Yeah.
congratulations to all the winners and all the other finalists for their enthusiastic participation. We did really see some great presentations today, and we would also like to uh, extend our sincere gratitude to LogHub for collaborating with us and making this event a grand success. We thank Mr. Ritik Luthra for sharing his deep and valuable insights, experiences, and for enlightening us with his incomparable knowledge. We also thank Ms. Pallavi Roy and Ms. Pranjali for constantly supporting us to smoothly conduct this national event. Last but not the least, we would like to thank all the participants for their patience and constant engagement throughout the process. Thank you.
Thank you, Akansha. Yes, I would also like to, say a few words. Thank you, I am Nagpur, for conducting such a beautiful event with us. We are very happy that we could manage to do event like this. I would like to thanks Ritik and Pranjali also, who made this event more insightful, and with their guidance we learn a lot about supply chain today. And other than that, I would like to also thanks Varun, also Vrinda. So they were there every time for every coordination. So all the coordination part goes to them. They did a great job. And last but not the least, all the students, thank you for participating. You guys really did a great job. So that's all from my end. Franjali, do you want to add something on that?
Yes, just one bit that definitely Varun is not here, but I would like
Yes, yes,
to.
Varun just joined. Yeah.
I had a class
Okay.
in between, so I had to drop off. Sorry for that, and I'm back, Franjali.
Yeah.
No worries. So I just wanted to say that Varun being a participant, being a winner, and now being an organizer, a good job there as well. So very well coordinated. I think I was also a little involved, not completely, because this time Pallavi has taken care of everything this time and done a fabulous job on that front. So definitely a big thank you to IIM. Second collaboration with you, and it has been as eventful and as good as it was last time as well. And we look forward to a lot of other activities in collaboration with you too. So thank you to the students, the organizers, and everyone. It's been a great evening. So
It's our
that's
pleasure, and we are looking forward to continue the collaboration, and even the next year and next 4 5 years down the line, we are looking forward to continue the event and conduct it in collaboration with LogHub. And thanks to all the participants for making it a grand success.
yes. So the communication to the winners around the certification and all of that will be taken. Pallavi will be in coordination with Varun and the team, and that's how we will communicate it to all the participants also whenever the certification program is taken care of. Yeah. So you'll hear something from us soon. So that was all from us. Pallavi, do you have anything?
No, that's all from my end. This was a great success, I would say. Everybody did well, and yes, looking forward to providing you with certification program and access to the apps, everything. Yeah.
All right. Thanks, everyone. Thank you for your time. Have a nice evening then.
Yeah.
Thank you.
Thank you, ma'am.
Thank
Bye-bye.
Thank you.
Bye
See you all.
bye. Bye bye.